Hey, hi everyone. Good evening. We'll start in 2 more minutes. Okay. Just waiting for a few more folks to join in. 2 more minutes. Yeah, perfect. So let's start then. 30 folks in. So today, what we'll be looking at is multiple. We'll be looking at multiple data structures. Okay. And multiple concepts that we will be using in the later parts of the course. So we will start with something called caching, and we'll be looking at multiple different data structures like sets, hash tables. We have already covered linked lists. We'll not do trees today, but we will look at the very basics that can help us build the remaining part of the course much more effectively. Okay, so with that, let's start with that in mind. So let me share my screen and let's talk about what I have in mind. So 1 second. I'm just sharing my screen. Let me know when it is visible. Just one of you can confirm if the audio is clear, the screen is visible. Perfect. So what we'll do today is, yeah, let's discuss a bit of caching first. So what is a cache, right? So can anyone tell what is a cache and why do we need it? So why a cache is needed, first of all? Anyone? No? So caching is mainly used as a piece of infrastructure that sits between the programming that sits between the client and the database, or the server and the database, right? And it basically helps us fetch information faster than what we can do from a database, right? So how caching essentially works is, so we have the server somewhere here. So this is, say, our server, and this is our database, and this database can be, as you might be knowing, so it can be a SQL database, where we'll talk later about databases, but this is what is about having storing relations, right? Relational data, structured data, or we can also have NoSQL databases. NoSQL databases, like a lot of things are very popular these days, like Cassandra, DynamoDB, MongoDB, right? So these are all NoSQL databases which store data in terms of documents or JSON files and not as the traditional rows and columns, right? Uh, so what a cache essentially does is it sits between the server and the, so this is where a cache sits. And what cache does is say server wants some data about some user ID, right? So it queries based on some key. It queries based on some key. And the cache, obviously cache also has a storage associated with it. So a cache will have a storage associated with it, and the storage will be a key value pair. Right. So now what the cache essentially does is that it tries to see whether that key is present in the cache or not. So it will first check if the cache has the value or not. So if it has the value, it will directly return the server the value. Right? If it does not have the value, what will it do? If the cache, so this is called a cache hit. So a cache hit is when the cache has the key it returns the value directly, right? So the other part is what we call a cache miss. So cache miss is what something that happens is the key is not present in the cache, so the cache cannot return it fast. So what it does is it queries the database. It will query the database, it will get the value, and it will update itself, and then it will return to the server also, right? So it's a three-step process. So cache does not have the key, right? The cache will not have the key. So what will it do is it will query the database for the key. So it will query the database. Just one second. Yeah. So it queries the database and it updates itself, updates the cache. So now the cache will have the information, and then it will reply back to the server also. Okay. So this is what a cache miss does. Now, so this is what, in very simple terms, is what a cache will do, right? So why do we need a cache in between the server and the database? Because database calls are expensive. Database calling a database or searching for a database takes a lot of time, generally order n time, okay, because it has to go through all the rows and figure it out. There are multiple ways to optimize it, like indexes. We are not going into that for now, but generally it takes linear time to query a database, okay, or log linear time if you use indexes. So if a cache, if you can see, it's a key value pair. It stores data in a key value pair. So fetch is order 1, right? So fetch is order 1 from the server. So if it is there in the cache, the fetch is order 1. Now there is a problem with the cache. So you can say that why not we keep the whole database in the cache itself, right? The problem with that is cache is expensive. So cache being very expensive, cache has limited amount of memory. Okay, there is limited amount of cache we can use. So the whole database we cannot fit in the cache. So there are multiple techniques in which we can optimize our queries. So say I called for, say I am continuously querying the cache, and some values I am not using at all. Okay, some keys I am not querying at all. One time maybe I had queried, and after 10-15 minutes I have not queried it from 10-15 minutes. Okay, so I can add something like a time to live kind of thing, that after 15 minutes, if it is not queried in the cache for 15 minutes, it will expire automatically, right? So there is something called a time to live in the cache. So cache is expensive, hence it is finite, and because it is finite, we cannot, because it is finite, we have to associate a time to live with each entry, right? With each entry. So whenever an entry is queried, we update the time to live, saying that okay, this was queried recently, so now it's updated. So again, for the next 15 minutes, it will be there in the cache. Right? Again, if it is queried, we update the time to live. So, but if something expires, we remove that item, right? We remove that key value pair. So that is called an eviction policy. Right? Eviction policy, eviction means removing someone, right? Eviction from homes means removing someone from their homes. So eviction policy will mean how you remove, what kind of strategy you want to use to remove a key value pair from the cache, right? So now the question comes as to what are the different types of eviction policies we can use. Right, one I explained was the TTL based eviction policy. So can any of you tell, like, just apply logic and think of what all eviction policies we can have, or what strategies we can use to remove an item from the cache? Anyone?
On the basis of recently used.
One is basis of recently used. Okay, so that is more of the TTL method itself, because whenever it is recently used, the TTL gets updated, right? So we can say something like, let's add them. So one is the least recently used kind of thing. So least recently used, so whichever item is least recently used, you remove it, right? So these are very popular. They are known as LRU caches. The next, multiple folks have mentioned in the chat, so I'll put them one by one. Okay, so we have two entries from, Shivam has mentioned FIFO apart from LRU, and Mirza has mentioned FCFO, so we can just have one. So it is basically first come, first served kind of thing, or first come, first out, not served, first come, first out, so first in, first out kind of thing, right? So that means that whichever element had come first, sorry, something got minimized, yeah. So whichever element had come first, we are directly removing that element. Okay, this might not be a very optimal solution, because even if something came first, might be it got used multiple number of times, but because because it came first, we are trying to remove that element. Okay. So now the question is, how do we implement a first in, first out cache? Okay, so we have to use data structures, and using the data structures, we have to create a first in, first out kind of a cache. So what all, before going into that, can anyone tell what all methods we will need for the cache? So if I have a class called first in, first out, what all methods do I need? And what all variables do I need as instance variables of the class? So we don't need push pop from the cache. So what things can we do on the cache? We don't need head and end in the cache. We don't need enqueue in the cache. So if I have a cache, essentially what do I do? What are the couple of operations I need in a particular cache? So try to see, look at here and tell in this diagram. So what all operations do you need in the cache? Correct. So Diksha has given the correct answer. So we need search. So one is search. So we need something called a get, which will, for now, let's consider the key value pairs are int. Okay. So everything is integers. So we need something like a get given some key. This is something we'll try to implement. And what else do we need for the cache? Anyone else? What else do we need for the cache? Insert operation. So we need something like a put.
And remove also.
We have to add elements to the cache. We can call it insert. I generally prefer to call it put because it goes nicely with get. So we have a key and we have a value, right? So this entry I have to put in the cache. So these are the two core methods that I need, right? What is the core property I need for a cache? What is the core property apart from queue and all? We will come to that later. But what is the core property that a cache should have? So if I have to have a constructor for the cache, right? If I have to have a constructor, what do I need to initialize it with? So if I have to build a constructor, what variable do I need to initialize? What should be the fundamental property of a cache? Okay, there is again something in chat. Let me see. A dictionary. Even before a dictionary, yes, we need something to maintain the key and values. But even before that, what do I need? So what did we discuss here? DB, array, those are all data structures, how you implement, right? A database, we don't need a database inside a cache, so that's out. We are not talking about also data structures. We are talking about the fundamental property of a cache. You can use an array, you can use a queue, you can use a linked list. Those are different things. You can use a tree, right? Whatever or a hash map or whatever data structure you want to use to implement it, that is on your side. I can have it different, you can have it different based on our logic, right? But what is the property of a cache should have apart from like these two functions, that is get and put? What is the property, the fundamental property that I would need to initialize in my constructor when I am building a cache? Anyone? The fundamental property that I need. You can get your answer more or less here, but it is not very straightforward. On the right hand side itself, the part I have marked. So again, note that TTL is associated only with an LRU cache. It's not associated with a FIFO cache because a FIFO is just first in, first out. So there is no concept of TTL. So you cannot configure a TTL in a FIFO cache. But any cache, what will you need? You will need the size of the cache, exactly. So Devanita has the right answer. So we need the size of the cache. So we will have something like size and we will initialize the size of the cache. Okay, so this always remember, if you are trying to implement a data structure, a cache, so you have to have a size. You cannot initialize it here, so you can have in size and you can give it in the constructor itself, right? So now we have the basic structure of the of a FIFO cache, right? So we need the size of the cache because we have to make it finite. It has to be finite, right? So now let's discuss how we can make it first in, first out. So now the question boils down to, we have to build a cache, right? So the first question today is we have to build a FIFO cache. With order one, cache has to be very fast, right? Remember, cache has to be very fast. So whenever you make operations on cache, it has to be order one operations. So you have to make order one get and order one put, right? And obviously it has to follow the FIFO property. So now the first question for today, how do you build up with data structures, no databases, how do you build a FIFO cache? Okay, so I've given you the basic structure of the cache on the left. Now you can think of list, queues, linked list, stack, whatever you want to. And with any data structure, you have to think of how you can get and put in order one time, right? For a key value pair, obviously. And you have to solve the problem. Okay, so I think we have good amount of people, 64 people apart from me, so we can have a good discussion on what kind of data structures we can use. So can you come up with something? So here I'll give you 5-10 minutes time to think of how you can build a FIFO cache. So note that we have not solved these types of problem yet in the last 4 classes, right? We have only discussed very straightforward data structure based questions. So now this is a question where you have to think of the data structure altogether, how you want to build it. So when you are thinking of a solution, try to think whether get and put can be done in order one time or not. Okay. And if anyone wants to unmute and discuss, like I have two answers, Rudnan and Devanita. So if you want to unmute and discuss, we can do that. We have good amount of time. And these are the problems that are really that will really build the base for competitive coding and data structures. So.
Sir, queue will take over one time to push and pop a value.
Okay, so queue can be used. Okay, so the Devanita says queue can be used, but the problem with queue, okay, you can do it. You can handle the FIFO part, right? But how do you handle the get and the put part?
The front method can give the get and the.
But front method will not give the get in order one time, right? So if you have a queue, say, so we have key value pairs, right? So say with a queue, say I have inserted, first of all, I've put like, so this is how your queue looks like. Say I put key 1 value 1, I have put key 2 value 2, then I have key 3 value 3, right? And then my size became full. My size became full, so this one got removed from the queue because it is FIFO, and then I put 4 4. I say the capacity of the queue, capacity of the cache is 3. It's equal to 3. Right, now say I have to search, I have to get 4. I have to get the value for 4. So the queue will take order in time, right? Because queue I am processing only from here. Or say I want to get for 3. Then also I have to, at the worst case, I have to go order n. Right, so get is not in order one time. Put is order one time, yes, because we are just inserting it at the end. If we see that the capacity is full, we are just removing from the front. So put is order 1, get is still not order 1. So Devanita, your question to you, how we can modify your solution since you have handled the FIFO part, or anyone else, how you can build on top of this to have the get also in order one time.
We can use a map instead.
You want to use a map instead. So you have a map.
An unordered map, not ordered.
Yeah, unordered map only. So it's a very C++ concept. So when we talk about hash maps in Java, it is always unordered. So just because our entries were all sorted, so it will look sorted. I'm so sorry. Yeah. So this is how the map looks like, right? And you have 3 3. So now get becomes order 1, but put, with the moment that your map has full capacity, which element do you remove? Because it is unordered, you don't have any way to know which is the first element, right?
What if we maintain a queue of the elements which came, of the order in which the elements came, and then a map of the elements themselves, so we can look for the next element through the queue and use the map to access the element.
Okay, so this is a good optimization on top of it. So you are using a queue and a map. So whenever you enter, whenever you get, you can directly get from the map. So you are done. And whenever you want to put, you check the size of the queue. If it is full, then you remove something from the queue. So what are operations you need to do? You first remove something from the queue, right? then you remove that from the map also. You have to remove that entry from the map also,
Yes, sir.
right? And then you have to update, you have to insert in the queue, and you have to insert entry in the map. So you insert 4 in the queue and in the map.
Yes, sir.
Okay, there can be one problem here with this solution. So if I put a duplicate key, so tomorrow a new, because if you remember the cache can be updated also, right? So if the database changes value and the cache fetches something, it will be updated, right? So we have not talked about dirty reads and writes, we'll not go into that, but cache can also have an update. So put, you can do initially say put, you did 3 right, and later you did say put 3 4. So obviously the value of the key 3 will be updated to now 4, right? So this has to be updated. So you will do this in the map, but how do you do that in the queue? That will again be order n, right? Because your queue now has all the keys and the values.
Yes.
Yeah, so this solution uses a queue and a map at the same time. So it is almost solving the problem. Just think about how do you update it, update a value in order one time. So Shivam has asked, before inserting, can we check or not whether it exists? So you can definitely check whether it exists or not in the map. But if it exists, then when you have to update, updating in the queue will take order in time, not in the map. Map is always constant time, update, read, write.
Sir, we can have a queue of the keys and a dictionary having the key value pairs. So we can know the order in which the items have came, and for update we could always use the dictionary.
Okay, so you have this is a pretty good complete solution. So we can have the keys only in the queue, because we are just worried about the order in which the keys came in, because it's first in first out. And we can have the map, we can have the hash map, we can directly update whenever we need to update, that is constant time. Now we don't have to touch the queue in an update situation because we have kept just the keys, right? And yeah, so even push and pop, not push and pop, like get put can be done in order one time, because if the capacity gets full, then we remove the key from the front, we remove that associated entry with the key, we remove it from the map, and we enter into the queue towards the end, right? So this looks like an order one solution. Perfect. So let's just formalize this. We'll not code it up, we'll just formalize it, what we discussed, everything, just for folks who joined in later also, and we'll just have the structure out. Okay, so we have a FIFO cache, we have a constructor with a size, with some size, we discussed that fundamentally the size is the only thing that you need to worry about building a cache, because that is its fundamental property, right? So we'll have to have some integer, right? And then what we need to do is we need to build the two things. One is the get with a key, and you have to build something like put with key and value, right? So this being the structure, so I'll just save this file. Yeah, so get, how do? We just check whether the, so we'll just now define the data structures what we need. So we need a hash map, right, which will have integer and integer kind of thing, right? So we'll have a hash map, What else do we need? So we call it a map, and we need a queue, as you mentioned. So queue, we cannot use queue. You can use the default one, or you can use a linked list to implement. Like in Java, it's implemented as a linked list, right? So you can do either one. So because I'm writing, I'll write pseudocode. I'll directly use a queue for now. Okay. You will build a queue of, say, integers. So this is not compilable code. I'm just putting the things here, and you can just say, yeah, you are done here. So get, what you can do is, as we mentioned, you check in the map. So if the map contains the key, you are great, good to go. So you can directly use something like get or default kind of thing, right? So you can check with the interviewer, if the map does not contain the key, what I need to get. So that is again that is also a corner case that you need to handle, right? So you can do map.get or default, whatever the key is, and say -1. That means the value does not exist. Okay, so you can directly use that to get the key. You don't have to do anything here, right? Because it's first in, first out. So we don't worry about the TTL and all these things. Put is a bit confusing. So for put, what do we do is we maintain something like a capacity also. So we maintain something like a capacity. Capacity is the size, sorry, we maintain like the current size kind of thing, right? And whenever we start working with a queue, we may say that the current size is equal to 0, right? You cannot use that and directly find the size of the queue, like queue.length kind of thing, if you have that function. But if you keep it, there is no harm, right? So what you can do is you can just check that if your current size is equal to the size, right? If these two are equal, then you know you have to evict, right? You have to remove. So you will do queue.dequeue. So you will remove from the front essentially, right? Or pop, whatever the function is. And if you know that this is equal, then you remove it and you insert the element at the end. So how do you insert the element at the end? So you say queue.enqueue, and these are again not proper functions, so pushback kind of thing. So you enqueue the key, because we discussed we'll store only the keys in the queue, right? We'll not store the values. The current size will not change, right? Current size will remain n. Else what we will do, if the size is not equal to that, so what we will do, we will insert it anyway. And increase the size, right? We insert it anyway and increase the size. Okay. What we have missed here, anyone? What we have not handled?
Check the value.
Check the value obviously is there, so we will just return or we will insert it in the map. I'm just writing this for now. We'll just be returning whatever the sorry, not returning, so this will be void. So we will be just inserting it right in the map. But what I have still not checked, anyone? So this part will be this part will fail for some cases. Yeah, go ahead, someone is saying something.
If it was already present.
Yeah, so if it is already present, what we need to do, Devanita?
We'll just replace word map of key equals to value.
So this will anyway handle this part. This part will anyway handle that, right? It will anyway replace the key, the value with this. So that is the functionality of a hash map. So whatever the existing value is, it will replace in order one time. That is done. But do we need this part?
We don't need it if it's already present.
Yes, if it is already present, we'll not need it, because otherwise what will happen? The queue will have two same keys, right? Duplicate keys. Right, so we don't need this part anyway, because it's a first in first out kind of a queue, so we don't need this part. So we'll directly check if map dot contains key. So if the map contains this key, if it doesn't contain, we need this, right? If it doesn't contain, we need this. If it contains, we don't care, we just update the value. In both cases, we update the value, just that if it contains, we don't add it in the queue. Okay, so this is more or less the code for it. This, as we discussed, get will have order one time. Get will have order one time. Put will have order one time, right? So we are sorted based on that, so we don't need to worry. And obviously the constructor anyway will have order one time. Okay, so we can use a queue directly, which is a first in first out kind of a data structure. Any questions with a FIFO cache? Yeah. Okay, I'll explain the code once again. I'll just wait for other questions also to come in. So yeah, let's discuss. I don't see any other questions. I'll request everyone again to join on time so that because I'll not go through the background again. It's already there in the recording. Just go through it. The background of what a cache does. So I'll just explain. So what we are trying to build here, we are trying to build a caching mechanism where get and put happens in order one time. Okay, and for doing that, a cache has multiple eviction policies. Eviction policies come into play when the cache has the size of the cache is full. So when the cache is full, we have to remove something to insert something new, right? And that can be done by multiple ways. Least recently used is one way. FIFO is another way. So we saw there are two different approaches. So first in first out generally means the key that came first, that irrespective of the number of times it gets used, it will be removed first, right? So whenever a thing gets full. So with that, we discussed that we need to have a queue. We have to have a queue for the keys. We cannot have a queue for the values because sometimes we might need to update the values, and updating a value in a queue might need order and time, right? So that's why the queue only has an integer for the keys. So this is just the keys, right? The map, on the other hand, helps us with the get and the put. So because a map is a data structure which always takes order one time for fetch and update, right? So map has the key and the value. So the other part, so we need the queue only for the FIFO part, only for the FIFO eviction part, right? And so what we are doing is we are just, when we need to get something from the cache, we can just do get our default key -1, which means that if the value is there, then it will return the value. If it is not there, it will return -1. As simple as that, right? And if I have to do a put, what it will do is it will just check in the, it will update the map obviously, but it will not add it in the queue. Why will it not add it in the queue? Because that element might, like if the element is there in the queue or the element was there in the map, that means it had earlier been used, so it will not be there in the queue. So it would already be there in the queue, so we don't need to add it again, right? We don't want duplicate entries in the queue because the queue just tells me the order in which they came, so it has to be first in first out, right? So we don't need to worry about that. I think one small thing we have missed here. So can anyone tell the one small thing that this code still needs to have? There is a bug in the code. So for those of you who are following this implementation, can anyone tell where the bug is? Line 19. So what is the bug here, Amritesh? So this is correct only. We are just checking if the map does not contain the key, then we have to go through all these. If the map contains the key, then we don't need to worry about the queue ideally, right? Because the queue will not change. The key already exists, so we don't care about the map, the queue, because the key is already there. In which case will this code fail? Anyone? There is a small
Null case, sir.
null case. We don't have. We have integers only. We have handled the case when the element is not in the cache. So we are doing get or default. So there is no null case per se. So think about when we are removing an element from the queue, what also we need to do.
Remove it from the map.
We have to remove it from the map. Perfect. So we have to do this here. So we have to map. So we have to maintain this somewhere. What we are dequeuing. So it can be a. We can call it a meaningful name, say such that a deleted entry, right? This has been removed from the queue, so we have to map.delete. We have to delete that entry, right? And map.delete will basically, it will remove that element from the map altogether, right? Cut size will not be equal to minus minus because an entry is getting deleted and entry is getting inserted, so current size will not reduce. It will still be the size of the array. So it will cut size minus minus we will not have, so that is not correct. So I think only if we had this miss, so this is now fixed. So this is how we can implement a FIFO cache. Okay, so all these small corner cases is what you need to handle, need to think of to solve the problem. Perfect. So any other questions apart from explaining the code once more? Any other questions, concerns? Nothing else? Awesome. So let's move on. Let's discuss. So the next question, how do we implement an LRU cache? With the same structure. So now you know the structure. You have a get, you have a put, you have a constructor with the size. How do you implement a least recently used cache? What does least recently used means? It means that there will be some TTL associated, but we will not have a TTL because we don't have a cron job checking the TTL, right? So we have to implement it the same logic using data structures. So what it means is that whenever I get or put, whenever I get or put or update a key, it becomes most recently used. It becomes most recently used. Okay, this is what you need to know for building an LRU cache. So whenever you do get, whenever you do put, and in the process of put, if it's an updating a key, updating the value of a key, then that means that key has become most recently used. Okay, so the next time you do an eviction, that will get least priority of being evicted. That will not be in front for being evicted. Okay, let's take an example. Say we have first, so we are doing put 1 So I'm just taking an example, okay? Then I'm doing put 2 see capacity is 3, put 3 put 4 Which one will get evicted? Quickly, which key will get evicted? When I have to insert 4? 1 will get evicted, right? Okay, so 1 gets evicted. Now I do get 2. Now which one will get evicted if I have to do a put? 3 will get evicted, right? because which one, if I have to see the least recently used, initially I had 1, then I had 2, then I had 3. So initially when I did put 4, so 1 got evicted because it was least recently used. Then when I do 2, 2 becomes the least recently used, right? So when I do put 5, 5, 3 gets removed and 5 becomes the most recently used. Okay, so then say I do get 2, get 4. So when I do get 2, 2 becomes most recently used, right? When I do get 2, 2 becomes most recently used. Then I do get 4, 4 becomes most recently used. Then if I have to put 6, 6, which one will get evicted? 5 will get evicted, right? Because 5 is the least recently used. So 5 gets evicted and 6 becomes the most recently used. So everyone gets this whole logic? Anyone with questions? Before we go into implementations, I want all of you to know what we are trying to solve for. So anyone with questions about the least recently used algorithm itself? Okay, so I'll explain once again because there is one request. So when we do put 1, 1, so we know there is a capacity of 3, right? So 1 becomes the most recently used. Then 2 comes, so 2, the key 2 becomes the most recently used. Then there is 3, so 3 becomes the most recently used. The capacity of the cache is 3, so the size is now full. So when 4 comes in, I have to remove something to enter 4. The eviction policy I have discussed is, we are discussing is LRU cache. So least recently used have to be removed. So among these 3, the least recently used was 1. So you remove 1, we insert 4. Now we do make a call of get 2. So we are getting 2 the moment we are getting 2 as per this law. What I have discussed, whenever I get put or this anything, it becomes the most recently used. So 2 becomes the most recently used. So 2 comes here. Then I put 5, 5. The cache is again full. So I will remove 3. And 5 becomes the most recently used key. Then I again do a get 2. So 2 becomes again the most recently used key. Then I get 4. So 4 becomes the most recently used key. Right? Then I put 6. I have to remove something because the cache is full. So I'll remove 5 and I'll insert 6. 6 will become the most recently used key. After this, if I again have to do a put, right? If I have to do an update, so I have not handled that case, I have not explained that case. So if I have to do put 4, 100, 4's value is 100. So 4 becomes the most recently used key. 4 becomes the most recently used key. Right? Nothing gets evicted. So this is how the LRU cache should operate. Does it make sense, Amritesh? Awesome. So yeah, so now anyone who wants to discuss an approach can think of an approach how we can do get put update in order one time. Put will have not the index. Okay, there is a question that whether put has index and value. So put has a key and a value. So it's a cache. So put will always have a key and a value. Get will always have a key only. Okay, so the cache will look like this only. Just that we have to now build a LRU cache. So if I have to just take this whole structure and build something new, which I'll save as LRU cache Java, and I'll paste it and I'll call this as LRU cache, right? And you just don't have these things, so you don't have the data structure as such that we have to discuss. So we have to ensure that get and put happens in order one time, right? So this is given to you. So how do you solve the problem? Current size I'm keeping it for now. We'll see if we need it or not, right? Okay, so Shivam has an approach in map. Along with the value, we can also store how many times that element occur, and lowest one from the queue will be popped up. Very difficult to solve it in order one, Shivam, because you won't know that which element in the queue is corresponding to that, right? So you have to search in the queue. Searching in the queue will become order n. So don't just think about using a queue. You can use any data structure. So try to rack your brains a bit. Don't think about just using a queue. For FIFO, maybe a queue was good. For this, maybe a queue might not be good. So if you see this operation, the way I have defined it, the way I have structured it, you can see that I am always deleting from the end, right? I am always deleting from the end. I am inserting at the front, but I am doing one more operation. Sometime I am removing from the middle, like this two I had done. I had removed from the middle. This was the list at that time. I had removed from the middle and put it in the front. Right? I have removed from the middle and put it in the front. So now what data structure can you think about which can help me do this operation, or which combination of data structures can you think about such that this work can be done very easily?
Linked list.
A linked list. So how will you solve using a linked list? So first of all, how can you check an element, Devanita, to find 2 itself, it is order n.
No, I was thinking we could create a map, and like with every element, the node of the linked list is attached to it. So like we can access the node with the element. So like element we can find in order of 1, and then the corresponding node if we can find, we can take that node to the beginning of the list.
Okay. So you are saying that if we can have 1 and not the value, we can have a reference to the list node which stores not 1, a reference to the list node which has 1, and you are saying that there will be a linked list here which will have basically the node essentially with keys,
Maybe it
right?
can
So
be a
do you want to
doubly
store anything else in the linked list?
I was thinking if it can be a doubly linked list, so we can for removing we can have the previous pointer point to the next pointer, and then we can take it to the head of the list.
Okay, doubly linked list. Okay, and what do you want to have in the key value? What do you have to want to have in the value? Like in the node, do you want to have the key value pairs, or you just need the key, or you just want to have the value?
The value will do.
Okay, so we have a value for 1, and we want to have a double linked list. So then 2 comes in. So again, a reference to 2, and it will be like this, right?
Yes, sir.
Is how you are thinking. Okay, and okay, because this is a doubly linked list, this left pointer points to null, and then you have say 3. So the third thing points to this. Oops. You are just having the values. So this, and obviously at the end, any node is there, it will be null and it gets updated because you are updating at the end. So now say 4 comes in. So when 4 comes in, you know that the size is full. Say I'm assuming you are maintaining something like current size. So when 4 comes in, the size becomes. Now
I was thinking instead of
Yeah.
putting it behind, we can put it in front so that the tail always remains the least recently used.
So in this case, anyway, the head will be the least recently used.
Yes, but then if we have to move it, move something, I was thinking if the head stores the most recently used and the tail store. Oh, okay, or we can go the other way around.
Either is fine, right? Because you have a head and a tail anyway.
Yeah.
But if we can, let's have your approach itself. So if you have a tail itself, so this basically is 3. This is 1. So note that what we have changed, everyone, is we are now building the same logic, just that the most recently used comes at the front. So whenever we are inserting in the beginning, right? For now I'll keep the node same because there are a lot of entries that I need to change, right? These arrows specifically, but it doesn't matter. So say this is the head of the linked list and this is the tail. There is no concept of left or right, so anywhere you can start from, right? So I'm just marking it like this. So okay, so now say 4 comes in. So what will we do? We'll remove from the tail. So we'll delete
Yes,
from
sir.
the tail and we'll insert at the head.
Yes, sir.
Right. Okay. So we have 4. We insert at the head. We remove from the tail. So this becomes null. This points to now null. Okay, done. So this is handled. This is in order 1 time. Okay. Get can be done in order 1 time because if the element is there, then I just see, okay, this node captures the value. So get can be done in order 1 time.
That
So 2 calls.
plus, sir, we need to move whatever when we have the get. When we find the let's say it's 3. In the next we find is 3. If we do get 3, then we take the reference to 3, and then we'll move the 3 to the head because it's now the most recently accessed. So we have a previous pointer and the next pointer. So we'll just link 2 to 4, and then we'll move 3 to the head.
Okay. So okay. So what would have happened if we use a single linked list? So what is the value of using a double linked list here?
I just want, for ease of convenience, previous and next pointers. But otherwise, I'll have to link it. I mean, to link the previous to the next, I'll have to search the entire linked list to find the previous pointer and then link it to the next pointer.
Okay. So in linked list, a delete operation is order n, and insert to the beginning is order 1. But in a double linked list, a delete operation is essentially order 1, because if you know the node, in both the cases, if you know the node, you can just point the previous one to the next one, and the next one, the previous one to the next one, and the next one's previous to the previous one, ideally, right? So basically constant operation in a double linked list. So let's discuss how a double linked list looks like quickly. So we have, say, 4 elements, these 4 elements, and they are linked like this. So we have discussed a single linked list earlier. Double linked list essentially nothing new. So each node will have a prev and the next pointer and some value. You can have as many values. For this question, we have kept 1 value as per Debanita's approach. And now if you have to remove this and you know which node to remove, if it was a single linked list, it was a big pain. So if you had a single linked list, and you knew the head, then if you knew this node, you could not delete it, right? Because if you deleted it, to go here, you have to start from the beginning and do an order and operation, right? But in case of a double linked list, it's very easy to do. You just see this, whatever the previous is from this pointer, the bold one, and then uska next will be this next, right? So you can just do this dot prev dot next will be equal to this dot next. Some focus issue here, yeah, some focus issue happening. I'm just trying to fix it. No, there's some issue with my marker. Just give me one moment. Just yeah, so this dot prev dot next will be equal to this dot next, and the next part you need to do is this dot next dot prev will be equal to this dot prev, right? So basically this points to this and this points to this. All these parts are now gone. Basically not all these parts, rather this part is gone and this part is gone, right? So 3 is now essentially dangling. So 3 is 2, say you cannot reach 3, from 4 you cannot reach 3. You can directly delete the node also if you want to. So you can directly now do, if you want to actually make it dangling and like taken by GC garbage collection, you can just do this dot prev null, this dot next null, right? So you will just remove these nodes also. So 3 is now a dangling memory space that will be collected by garbage collection. So you are done. So removal in a double linked list is essentially order 1, right? So now you remove it, then back to the problem, you have to insert at the head, right? Because that is most recently used. Okay, so you insert it at the head. Then how do we update it? So what do we do for an update? So get and put are in order 1 time, but how do we update? Say if I do a duplicate kind of a thing, will that work here?
It's a map, so it should.
Okay, so can anyone think and tell whether the update will work properly or not?
So does the update mean it's again the most recently used?
Yes, yes, update will also mean it's the most recently used.
Then it can be the same as delete. We find the key and then we update it and then take it back to the head. And the value of the node, and then we take it back to the head.
Okay, so update and put will basically do the same thing, right? So you don't have to do anything extra for doing an update. Okay, so you are saying that we'll just delete it from there, and whatever the new value is or whatever the old value is, we'll just update the node's value and put it in the front. So that will again be a constant operation. Okay, so get and put, all the conditions are handled. I'm just trying to think if we have to delete. Yeah, so delete from the tail is a constant operation, because in the linked list you are maintaining, in a double linked list we generally maintain the head and the tail also, right? So that is a constant operation anyway. Okay, anyone sees any problems with this approach, or does it look that everything can be done in order 1? Or anyone has a equal or even better approach in terms of the maybe the space part. No? Okay, then we'll keep this as an approach itself. So a good approach, we are handling everything in order one time, more or less. One small thing that I need to emphasize when you build a linked list or a double linked list is that always have a dummy head, right? Always have a dummy head, and in this case have a dummy head and dummy tail. So what is the benefit of that, anyone? We had discussed it in the linked list discussion. So what is the benefit of having a dummy head and a dummy tail? Anyone tell why we need a dummy head or why we should have a dummy head in a linked list?
Sir, if there is a dummy head, then our linked list will behave like a circle type, sir. That there is, it will be like center, sir.
No, it will not be a circle. So the tail is not pointing to the head. I just want to have a separate pointer. Okay, Dhruti has something. I didn't get Dhruti, so I didn't understand what you have written. So to work on it, subsequent elements. No, but where do we have a benefit of having a dummy head? Say in a normal linked list. No one. So generally we need to use it because say we are deleting from the front, right? If we are deleting from the front, then you have to always write separate code for checking whether if you're making a delete operation, right? If you're making a delete operation, you have to always check that okay, whether my prev was null or not, right? Say in this case itself, I am deleting, say I am deleting 3, right? In this case, in the double linked list. So I did not check. I just wrote this dot next dot prev equal to this dot prev and this dot prev dot next equal to this dot next. Now this part, if this was the first node, so this dot prev was reaching to null. So this would have given you a segmentation fault, or not a segmentation fault, a null pointer exception, right? Because this dot prev was null because this was the head, right? If 3 was the head, right? So whenever you delete something, because you don't have a dummy node, you have to always check, okay, whether the next is null or not, whether the previous is null or not. If it is null, then you have to handle separately. If next is null, you have to handle separately, right? All these problems. So better to have a dummy head and dummy tail in case of a double linked list. In case of single linked list, you just need to have the dummy head. Okay, just so that in case of deletions, in case of insert befores, right? Insert before also, that is a problem. If the head is not there, you say that the new node is the head, or right, insert before an element. So if the before element is nothing, then you have to create a new head and insert. So you don't have to do anything. So insert before works very normally. You don't have to check whether the before element is null or not. Right? So all these checks you can handle, and that actually gives you much more elegant code. Okay. So yeah, this is one of the important concepts of implementing a cache of two types, LRU and FIFO. The LRU cache implementation, I think LeetCode has that problem. I'm not sure about FIFO cache, I don't remember. But if you search for it, LRU cache, you will get that, I definitely know. But these are generally the different ways in which you can implement a cache using a data structure. Okay. So yeah, mostly this. So any questions on the cache front before we move ahead? So I'm not writing the code for this one, okay, because the code for this one is easily available using a double linked list, so you can get it. And number two is I just wanted to explain the approach. Just writing the code will take time. Like I will just spend the next 20 minutes writing the code, so I'm not going into that. I hope the approach is fine. If not, let me know. I'll share the code across. But that will, I'll again just do a copy paste and find it out, right? So I can just show that. Maybe that will be an easy thing to do. So LRU cache, yeah, LRU cache implementation is there somewhere in LeetCode. So I think my screen is still visible, right? So am I sharing the whole screen? Yeah. So yeah, this is LRU cache implementation. Look, yeah, so hash table plus double linked list is one of the standard implementations to have. Okay, so you can take a look at this. Does this have dummies? I'm not sure. Yeah, so we have a head and a tail. Okay, so head and the tail themselves are dummy nodes. Okay, these two are dummy nodes. And whatever you insert or delete, you will be deleting after the head or inserting before the tail kind of thing. So you don't need to handle cases separately. Okay, so this code is there. I'll just put it in the meeting chat so that all of you can look at it. I'm just everyone. So this is a good solution. This is a decent solution for the problem. Okay. So let's move forward. So now we'll discuss, so enough of hash tables. So we've discussed hash tables, we have discussed double linked lists. So now let's try to discuss a set. So can anyone tell what is a set? What does it do?
Stores unique values.
So a set stores unique values, right?
In
So
a sorted order.
yeah, go ahead. Sorry.
In a sorted order in C++.
Yeah, so we are just discussing an unordered set for now. So we are not discussing a C++ set. So it's more of a Java hash set kind of thing. Okay. So we'll be trying to implement a set now. We'll be trying to implement a set. So how can we do that? Just that a set will have obviously two functionalities. One is whether the element is there in the set or not, right? So a get kind of a call. So if the element is there in the set, great. If the element is not in the set, then you return a -1. And put means if the element is already there in the set, you don't put it, because set does not allow duplicate elements. If the element is not there in the set, you put it and be done with it. Okay, so let's add a bit more twist. So let's say that when I do a get, so there are three things. One is a put. So we are discussing a set here. So we'll say that get We'll check, we'll return whether element exists, right? So get is a Boolean function. Okay, so get is a Boolean function. So it returns Boolean, whether the element is there or not. Put, on the other hand, again is a Boolean function, returns true if element is inserted, if element can be inserted. If not, it will return false. Okay. So till now, okay, how will you implement a set data structure with the data structures you know? With how can you implement a set data structure? Okay, I have two answers from Shivam and Rudnan. So we can directly use a hash map. We can say that, okay, if the element exists, I return true. If the element does not exist, like if I'm doing a get, if the element exists, I return the value, or whether the element exists or not, that is also fine, true or false. And if obviously you have to do that, but because there is no value associated, just the keys. And if I have to put it, I check whether the element is there or not in the map. If it is there, I return false. If it is not there, I insert it. So what will be the key and value pairs in the map? Shivam or Rudnan, what will be the key or values in key and values in the map? Because we are just discussing keys here, right? There is no concept of value. Yeah, so it can be true or false. The value can be true or false. The value can also be the item itself, any dummy value. It can be 1. It can be anything, right? The value can be anything. So that's fine. But when you are removing it, either make it -1 or you remove it directly, right? Better to remove it directly from the map also. So till now it's all set. Let's add a bit more complexity. So now let's say there is a third function. There is a third function called get a random number. Okay, so get a random number, what it does is it gets a random element from the set. Okay, it gets a random element from the set. From what all elements are there presently, it gets a random element from the set with equal probability, because all the elements are one time present, right? With equal probability. So now, how do you make a set? So till now we have solved it, get, put, order one time, but get a random number also. So how do you implement all these three in order one time? With using a map, you cannot get a random element with equal probability, right? In order one time. So how do you modify your logic?
This is a very hacky approach, but when we are storing the hash map, we can just store a counter as 1, 2, 3, 4, 5. We can keep incrementing, and then for the random function, we can just run a random function till the current count it is, and then it has an equal probability of picking a random number, and then we return that.
So what will be the key and value in the map?
The key is the value is instead of true or false, we can just have the get input is the key, and then the value is just the counter.
Okay, so you are saying that you have
What I'm trying to do is to
whenever
create
I'm inserting that frequency, you are putting as that number you are putting as the value,
yes sir,
like this.
yes sir.
Okay, and what do you do for get random? How do you get it?
The recent value is 4, so like we can do a normal random function from 1 to 4,
Then
and then oh, it is not.
yeah. So anyone else? What will be the problem with this? So what is the problem that Dipanita just figured out?
Sir, we cannot know which element corresponding to which index.
Exactly. So you cannot query a hash map with a value, right? So it's a one-way game. So can we take this approach itself and make it a bit better in terms of the logic part? Anyone? What can we do further to solve this? Okay, I'll add a bit more functionality to it. You also have to delete from a set. So a set has get, put, and delete also, right? So get, put, and delete could have been solved by the initial hash map approach, but get a random number, for that we are trying to solve it. So when you try to solve it, also think of the delete. So you have to delete that element from the set.
Sir, we
Yeah.
can have a hash map and with an array.
With
So
an
hash
array.
map
Okay.
contains the items and the corresponding index in the array.
Hash map contains an item and the corresponding index in the array. Okay.
So if we
So
want to delete we can just go to that index and delete. And if you want a random number, you could generate a random number from the array length and go to that index.
these are the indexes. Okay. These are the indexes we have 0, 1, 2, 3, and you are saying that there will be a list where the indexes, where the values are there. Am I right? This is what you are saying?
Yes.
Rudran? Okay. So now say I want to delete 2. What will I do?
Search it in the list, go to that index and delete that.
Okay, so I'll go here, I'll delete this, and I'll delete this entry. Awesome. Who will tell the problem in this approach? Anyone?
But we could not know which array index are getting wasted.
Array indexes don't get wasted. So how do you delete it basically?
Instead, it should be better to use a double linked list.
Okay, if you use a double linked list with a
hash map, like the
with a
previous
hash
approach.
map, then what do you have here? Then how do you generate the random function? Okay, so the problem that Rudnan figured out, just for everyone, is that if you delete this node, then this becomes 1 and this becomes 2, and then you have to update all the entries, right? Sorry, this becomes 1 and this becomes 2. That becomes an ordinary approach, right? So deletion is not a very good way. It is not working in a good way. So the next approach comes that we can use the same LRU cache approach. We can have the nodes here and we can have a double linked list because deletion is order 1, right? But now the problem is you don't have a way to figure out get random, right? So now we have 3 minutes time for the class. Let's take 5 minutes time. Can anyone tell how we can intelligently delete it from the map, from the array? Let's take we had an array itself. Can anyone tell how I can delete it intelligently such that I need to make minimal changes in the map, not order n changes?
Sir, we can swap and delete the last one, sir.
Can you explain a bit? I don't know who answered. Yeah, Rohit answered. Yeah, go ahead, Rohit. Yeah.
Sir, if like index 1 is to be deleted, sir, then we will swap it with the last one, sir, and then we will delete the last one. Then we do not need to change the index of the middle one.
This becomes like this, a list, a deletion happens well, but what one small change you need to do?
Hash map also needs to be changed, sir.
Correct. So the hash map entry for the last element needs to be updated to the latest entry. So this becomes your 1. Right? This becomes your 1 and this remains 2. So you just make one change in the map. You don't need to make order n changes in the map and you are able to solve the problem. So with the hash map and with a array list itself, you cannot use an array because you don't know the fixed size of an array, right? You cannot use an array here. You have to use a variable size, something that continues to get added. So you can use an array list, and with a hash map, you can solve the problem provided you make the swap, you make the deletion in order 1. And deletion from a list in order 1 time only happens when you swap it with the last value, and you have to modify the map also. Right, so the map at any point of time has the values from 0 to n-1. So when you do a random kind of a function, when you create a random call, so you just need to check in the array. You generate an index between 0 to n-1, 0 to n kind of thing, right? So you always have the size of the array list handy, and you generate a number and just return that value. So you know that is in the map. So get random works perfectly. Right, get and put will directly work, and delete we will need if the set has like fixed size, right? So you might have to delete something when you insert something new. So all these things can be done easily. Okay, so what did we learn today? We learned about hash maps. We haven't gone into internals. We'll reserve that for some other day. We learned about caches actually in detail in the first 15-20 minutes, how the eviction policies in caches work. Then we tried to implement them using data structures. We did the FIFO implementation, we did the LRU implementation. And finally, we looked at using how do we use a set effectively, right? Using a set effectively and then create a randomized set, also using a map and an array itself. So not necessarily a double linked list will always be handy. Okay, we also looked at queues. And yeah, I think these 3 questions are pretty good for a start into these types of problems where you have to build a data structure from scratch, right? We'll be looking at such harder problems even tomorrow, where we will be trying to build a data structure with some properties. Okay, so today we looked at LRU cache, we looked at FIFO cache, and we looked at randomized set, right? Tomorrow we'll look at few other similar problems of this sort. Right, so with that, questions, concerns, anything from your end before we wrap? Nothing. Okay, cool. So since no other questions, we'll wrap. We are on time. So tomorrow we'll discuss same time. Do join in. We'll talk more about these types of problems itself. Okay. Thank you. Bye bye.
Thank you, sir.